In this video, I'm going to be attempting to upgrade the soldered storage on this M1 Apple Mac Mini. Now as you can see here, I've got two chips here, and these of course are the largest capacity chips that a board like this supports, and will give me a total storage size of 2 terabytes. Now if we go ahead and take a look at the machine here, you can see that it currently has a 256 gigabyte configuration on the motherboard here, which of course is the base configuration. Now this machine was actually brought to me by a fellow YouTuber, Luke Miani, and he is actually here with me.
Hey, what's up? My Mac Mini is about to get juiced. I'm so excited.
Yeah, well anyway, he's here with me to perform this upgrade, and while this is not the first time such an upgrade has been done, this is the first time that I've done such an upgrade. So it will be a little bit of a learning experience, and of course a bit of an experiment in this case for me. So with that, the first thing I'm going to do here is I'm just going to get the Mac Mini taken apart and show you exactly what we're going to be working with here. And then we're just going to get started by desoldering the original NANDs and installing these NANDs, which I actually got from AliExpress in China, and they cost me a grand total of $180. So when you compare that, I guess, with the $800 Apple charges for a 2 terabyte upgrade when you order one of these machines new, that is actually a pretty good deal, I think. And even with the labor involved, I think it will still be well worth doing it this way rather than paying Apple's $800. So with that, I'm going to go ahead and get the Mac Mini taken apart, and we'll proceed to desolder the original NANDs. Alright, so as you can see here, I've gotten the board out on my table here, all disassembled and ready to go. I've also applied a weight to it here, that way the board doesn't move around when I'm trying to mess with the underfill and all that. So with that, I'm just going to turn on the hot air. I'm probably going to turn it to around 280 to 300 degrees. You do not want to go too hot on this, or you will damage either the NANDs, not that it's a big deal in this case, or the board. So we'll just turn it to about 300 and start removing the underfill around the edge of the chip. So first, of course, you want to make sure it's nice and warm before you start working. The warmer this underfill is, the easier it will be to remove. And you do not want to go too deep with this tool or with too much force, or you will scrape away the solder mask, which you obviously don't want.
Yeah, that's not good. And these are some pretty deeply layered boards too, so you don't want to get anywhere near.
Well, you don't want to take the solder mask off because it'll allow solder to get on spots where it's not supposed to be.
Right. I can see little chunks of underfill blowing off.
Yep, that's what you want. It comes off in chunks. Alright, so at this point, I think it's well enough separated now from the outside edges, especially these two little resistors right here, that we can now begin the process of actually removing it and then get this tool underneath the chip to pry it off.
Oh god, that's scary.
Yeah, it's really scary. So the key here is you want to make sure that the solder is fully molten before you start putting this tool under here, or you will cause damage like ripped pads and stuff like that.
Ripped pads are like a nightmare for board repair.
Yeah, so we definitely don't want that to happen. You just gotta get a feel for it. You do not force this in there. Like there, it's starting to go now.
Oh yeah.
So we're gonna get this nice and hot, the whole thing.
Dang. There it is.
Okay, all pads look good. That's good. And our components are still good here. That's good. All right, so let's move on to chip number 2.
Time to do it all over again.
So we're gonna go down here to about 300. Start off with.
I'm surprised that the underfill was that difficult to remove given how relatively easy it was for you to separate it.
The issue was, it was just, the board is so thick,
Yeah.
it sinks a lot of heat.
Oh, I see.
So it was more of the solder's not molten yet than the underfill being a pain. Okay, that's separated, so now, here we go again.
Oh, look at that. Beautiful.
All right, the hardest part's done.
Those pads look pretty good.
Yeah, no ripped pads that I can tell.
That's fantastic.
All right, so now that the NANDs have been successfully removed, as you can see here, the next step is to clean off all of this residual underfill, and it'll also clean off some of this residual solder as well. So we'll just go ahead and take the hot air once again and heat the board. And once the board is up to solder melting temperatures, we can take this tool and just kind of scrape the underfill off. Alright, so now with most of the residual underfill removed, we're going to go over it with some fresh leaded solder and some flux just to make sure all the pads are good and ready to be soldered to. So we'll go ahead and first apply flux. And then we will take the soldering iron and just tin all the pads. This will also help remove some extra underfill that we might have missed. Alright, and with all the underfill, or all the pads with fresh leaded solder applied, we're now going to go back over them with some solder wick to remove as much of the solder as possible. Alright, and that looks pretty good there. So the last thing I'm going to do is clean it with some rubbing alcohol and a paper towel just to get all that flux off of there. And then we'll take a look and make sure everything looks good. Alright, so as you can see here, I have successfully removed both NANDs. All the pads look to be intact for the most part. There is one pad, I don't know if you can make that out right there, that looks like half of it is gone, but I don't think that'll be any sort of problem there. And then the other one, of course, looks pretty much perfect. So yeah, we should be all set to install some new NANDs onto this board. Now, before I install these NANDs, if you go ahead and take a look at them here, it does look like they've been reballed. You can see there is solder on them. So I can focus that in better. Yeah, there is solder on them, but if you look at it from the side, there's barely any height to that solder. So what I think I'm going to do, just to be 100% safe here, is I'm going to go ahead and reball this a second time, just to add some extra solder onto both of these. That way I know for certain that they'll solder without any sort of problem. So with that, I'm going to go ahead and get my stencil out for these, and we'll apply a little bit more solder to them. Alright, so as you can see here, I've gotten the necessary BGA stencil out here. You can see right there is the correct footprint for these NANDs. So I'm just going to go ahead and apply it. And now that the NAND has been applied to the stencil, we're just going to use some solder paste to reball this one. So to do that, I'm just going to squirt a bunch of solder paste on there. And then I'm just going to take this tool and press it down into all these holes. And now with the solder paste in those holes, we're just going to use the hot air to melt it onto the pads. Alright, and as you can see there, all the solder is now melted onto the pad, so now we can just remove the chip. And with the chip removed, we want to heat it one more time, just to smooth all the solder out. Actually, I might actually apply a little bit of flux to it as well. Alright, and that looks really good. The solder balls definitely have a lot more height to them now, which will make certain that it fully solders to the board. So now, of course, we just have to repeat that process with the second chip, and then we'll be ready to install them onto the board. Alright, so as you can see here, I have finished reballing these chips, and as you can see now, they have much more height on those solder balls than they did before. So that is going to be much easier to solder. Let's see if I can get that better. Yeah, so that's going to be much easier to solder than they were with the stock balls that someone else had already put on them. So with that, we're just going to get the board back up here and solder these chips onto the board. So hopefully it should be relatively straightforward and simple, and it should just hopefully work afterwards. So we'll get the board back out here and solder these chips on. Alright, so as you can see here, I've now gotten the board on the preheater this time for final soldering. I just want to put it on here, not that it's really necessary in this instance, but I always like to have it in the preheater for this, especially since we no longer have to deal with any of the underfill. So to get started, I'm just going to turn on my hot air to about 300 degrees. And that should be enough because, of course, these now have leaded solder on them. So now, with that warming up, we'll just apply flux to all the pads. Good. And then we will simply take our new NAND chips that we just finished reballing, align pin 1 to this top corner, closest to the SoC, and then we'll simply heat them and solder them onto the board. So of course the first step here is proper alignment. Alright, I think that alignment's pretty good. I mean, these have really big pads, so it's not like hugely crucial that the alignment is perfect on them. So with that, we'll just go ahead and solder them onto the board. And there we go, simple as that.
Wow.
They're soldered onto the board. So now it's the moment of truth. We're just going to go ahead and reassemble the machine, hook it up, and see what happens. Of course, we're going to have to do a DFU restore on this thing, but hopefully that all goes well. Hopefully everything's soldered and everything's good. And in theory, if all that's correct, we should have no issues getting it back up and running. Alright, so before I fully reassemble the machine, I just wanted to show you how the chips look now that they've been soldered on. So you can see that they're all uniform on all sides, which is exactly what you want to look for. You can see they're fully seated, and if you look on the edge of them here, you can kind of see the solder balls under there. Because like I said, I made them pretty much twice as big as they were originally, so the chips will sit slightly off the board, which I think is what you want, really. That also ensures that all the solder balls do indeed solder to their pads correctly. So with that, we'll go ahead and finish reassembling it, and we'll give it a test and hopefully DFU restore it successfully. Alright, I've got the Mac Mini hooked up here. As you can see, I've got an older Mac Mini on top of it, but we're going to use this to DFU restore this one. I do have it in DFU mode, as you can see by the amber power LED there. And as you can see here, I've got Apple Configurator 2 open on this machine, and it does indeed detect it in DFU mode. Now, as of, I believe, like a few months ago, Apple has changed something in one of the routines in this piece of software that, according to what I've heard, I don't know this for certain, but according to what I've heard, will prevent you from restoring a machine that has wrong or unprogrammed NANDs installed. So hopefully by using this old version, which I downloaded probably over a year ago, and this machine is actually running Big Sur, as you can see right here, hopefully this will allow me to restore it successfully. So the only thing left to do now is to restore it. Alright, so with all that ready to go here, I've already downloaded the Big Sur IPSW just to make 100% sure that we don't run into any issues due to the newer software. And in theory, all we need to do is drag it over to here, and it should restore it for us. So yeah, it says, do we want to restore it? I'll just say yes, and we'll see what happens. Please work, please work. Alright, so I guess I'm just going to wait for this. I don't have a monitor hooked up to the Mac Mini, because I don't have a second one to hook up right here. But we're just going to hope it's working, and in theory, if this completes successfully without any errors, we should be all good to go. So I'll just go ahead and pause the video here and resume it once we have some sort of update. Alright, so I've tried to restore the device quite a few times now with these new NANDs installed, and unfortunately I am unable to get it to successfully restore, no matter what I try. Every time I attempt the restore process, it always comes back with an error saying an error occurred while formatting the NAND. Now I'll put a picture of that right here so you can see exactly what the error message was. But these specific NANDs I got, as you saw at the beginning of this video, were labeled 0 and 1 because they were supposedly sold as pre-programmed NANDs for a specific MacBook. Now, they weren't programmed for a Mac Mini specifically, and I don't know, like I said, if there was any difference between, you know, the firmware that might be on the NANDs from the MacBook Pro, the Model A2338 that they would have come from, and the Mac Mini. And I also wasn't sure about the exact position on the Mac Mini motherboard where each chip was supposed to be, because I don't actually have schematics for this board. So the correct order is this chip right here is supposed to be chip 0, and the chip right here is supposed to be chip 1. Now, when I initially put those NANDs on here, which are the ones currently on here, the markings got removed from the rubbing alcohol that I had to clean them off in. But when I initially put them on, I believe I might have had them swapped. So I did try swapping the positions of the chips and restoring it again just to see if that would make any difference. And it did not. It came back with the exact same error, no matter which position the chip was on. So I can only assume that A, these chips are either bad, or maybe one of them is bad, or they were not, or because the firmware on them was designed for a MacBook Pro instead of a Mac Mini, that could have been why they didn't work. I really don't know. Now, the special part about an M1 machine is what's supposed to happen is it's supposed to rewrite the firmware on these chips when you do the restore process. Now, from what I've heard, if the chips are not blank, which obviously these would have been pre-programmed if, you know, they were exactly as I had paid for them or bought them from that AliExpress listing. So if they are not blank, the restore process will not rewrite firmware onto these chips. But what I've heard as well is that if you put blank chips on here, so brand new blank NANDs, that the restore process will rewrite the SSD firmware on them. So what I've got here are another set of NANDs. You can see they're the same type of NANDs, KICM223. You can see the part number right there. And of course, there are also 1 terabyte NANDs each. But these were sold as brand new blank unprogrammed NANDs. So we can put these chips on either position on this board, and hopefully that will solve the issue. And hopefully we can, with supposedly blank NANDs installed, the board or the restore process will rewrite that firmware and in theory should complete successfully. So what I'm going to do now is I'm going to repeat the same process that I did initially of removing these chips, reballing these chips, and then soldering them on in the place of these. And in theory, that should be all we need to do. Now, of course, since I have already removed these chips before, we don't have any underfill material anymore to worry about, so the process will be much, much easier than it was originally. So with that, I'm just going to go ahead and put these new chips on off camera. They do need to be reballed. As you can see, the solder balls are not very thick on those, and just like the ones I put on this board, these need to be reballed as well. So I'm going to reball these, get them installed onto this board, and we'll proceed to restore the device again. Alright, so as you can see here, I've got the Mac Mini with the new NANDs installed, and I reinstalled the heatsink, as you can see here, and I have changed my restoration setup just a little bit here. So I've actually switched over to using another Mac Mini, M1 Mac Mini, as you can see right there, and I am now going from USB-C on that Mac Mini to USB-C on the Target Mac Mini here. And I've got it hooked up to an iMac just as a screen at this point. This will eventually go inside here, but I haven't gotten to that just yet. But I've also gotten a copy of Ventura on there, as you can see here, and we're just going to use the latest version of macOS with as new of a machine as I could possibly get here to restore this one. So we'll go ahead and open up Apple Configurator 2, and as you can see, it does detect the device in DFU mode here. So what we're going to do is just right-click on this and select Restore, and we'll just restore it with the latest version of macOS available. So it is going to have to download the system here. This obviously will take just a little bit of time to complete, but when that's done, I'll resume the video and we'll see what happens. Alright, the download is almost complete here, so we're about to see if it decides to work this time. Okay, here it goes. Got the white LED on now, which means it's trying to boot. Alright, so no matter what I tried there, I tried various different machines, various different operating systems as the host system, various different IPSWs of older macOS versions, and no matter what I did, I would still get that same exact error. I believe it was error 4010 or something like that. So what I've decided to try here, and this is basically just on a whim, I have really no idea if this is going to work or not, but I've taken one NAND, this one right here, that I initially got, which I installed in the first part of this video with that weird error formatting the NAND error that I initially got. And I've also combined that with one of those new NANDs that I got right here. So I've put the original NAND that I initially attempted in spot 0 here, and one of those new NANDs in spot 1 there. So, like I said, I really have no idea if this is going to work. If it does work, that means that either one of the NANDs that I gotten was bad in both instances, or maybe there's some weird programming on them that is wiped by putting two different NANDs on there. I really don't know for sure, but we're just going to go ahead and get this machine hooked up now that I've got it reinstalled in its chassis, and we'll attempt to restore it once again. Alright, so I've got the machine now in DFU mode once again, as you can see here. I've got that same combination of NANDs I just showed you, and I've also got it hooked up to this monitor here, since I no longer need this as the monitor for my host system, so we can actually see if the Mac Mini is showing anything on the display and what it's exactly doing. So I've already got it hooked up here to the other M1 Mac Mini, so we're just going to attempt to restore it once again, just like we did before.
That step 2 is where we had been getting stuck, or no, it was...
It was the next step after...
Yeah, after
this, when it was, I think it just said restoring system, step 404. So let's see here. And just like my last attempt, this is with the latest version of Apple Configurator, latest version of Ventura, and we're installing the latest version of Ventura. So from what I've heard, this should be the best combination when you do an upgrade like this. But if we do encounter any errors, go through my entire troubleshooting process of using different machines and older OS versions, but hopefully this just works.
Okay, step 4 of 4, installing system. This is where we got stuck before.
And we've got the white LED on the Mac Mini,
Oh, yes.
which it did do before. Oh, and we've got a signal on the Mac Mini. That's good.
We have seen that before, though, I think. We got to the point where we
Yeah.
saw that blank loading bar.
Yeah. Oh, look.
Oh my gosh! Progress! It's moving, it's moving, it's moving!
All right, and it had already errored here by this point with the other. So somehow mixing those NANDs seems to have actually worked.
Holy cow.
So we'll see.
We're making
what
progress.
happens. It's definitely doing something else than it did before, that's for sure. All right, so the Mac Mini just shut off here, and it seems to be rebooting. So we'll see what it does.
Still a white light on the front. That's
Yep.
a good sign.
Yep. Oh, turned off. It's back on. No recovery mode error. That's good. Oh,
That changed. Oh,
we got a video signal.
we got a signal. Come on.
And there it is.
Oh my god. Oh, and it's gone.
That's
What
just my
the
monitor.
hell?
Okay.
Well,
let's get that straight, and we'll set it up and see if it detects the full 2 terabytes of storage. All right, so as you can see here, I've just completed the setup here. So let's go ahead into About This Mac and check out our specs. So there's the main specs, 8 gigs of RAM, same serial number, of course. Go in here, and there it is. Check that out. 2 terabytes of total storage. So I guess I'll just go ahead and check out disk utility as well, just to see what it shows there. Of course, 2 terabytes there. Go to the main drive. You can see it actually writes specific firmware to the NANDs with like a specific SSD model name, so that's kind of funny. But there it is, 2 terabytes. We've got, of course, 2 terabytes of usable space on the main set of volumes here. So yeah, I definitely consider that a successful upgrade. So with that, that has been the complete upgrade from 256 gigabytes to 2 terabytes of onboard soldered storage on this Apple M1 Mac Mini. So, hope you enjoyed this video.